Hello, hello. Welcome to my little Unit 2 summative assessment video. I want to apologize about not being in class on Thursday. It was not really anything I could control. My internet went out at about noon on Thursday and didn't come on until later in the evening. So, yeah, I do apologize about that. That's why I'm making this video, and that's why I will be hosting a optional review session Sunday at 4 p.m. I'll make an announcement about that in Canvas later. But if you're watching this video and you're potentially interested in coming to my optional review session, once again, that will be this Sunday at 4 p.m. I'll send out some info about that and a Zoom link in an announcement later. So, for today, in this video, I'm just going to go over what you're going to see on the summative assessment. I'm going to talk about the study guide a little bit and talk about all the resources that you have available to you. Okay, so here are the dates for the assessment. Depending on which class you're in, it'll be Monday or Tuesday, and it's going to be over these 5 different topics: properties of subatomic particles, isotopes, average atomic mass calculations, electron configurations and Bohr models, and Coulomb's law and periodic trends. Okay. And as I'm sure you're aware, all the notes and videos for these topics can be found in Canvas. The format is it is going to be a Canvas quiz. You will need to be in class from your designated time. I'm going to give everybody a passcode that will allow them to start the assessment. If you are not there in class, then you're going to have to take it at an alternative time. It is open notes, open assignments, open internet, okay, so you can have all the resources you want. The only thing that I'm asking you not to do is to communicate with your peers while you're taking the assessment. It's going to be multiple choice, no short answers this time. It's going to be about 6 questions per topic, so 6 questions times 5 topics is about 30 questions total, which means that everybody will probably be able to get done in about 30 minutes, maybe a little bit more, a little bit less, depending on how fast you work. You're going to get a score from 1 to 5 on each section. If you're absent on the day of the assessment, then you're going to get a missing for each of those sections until we can schedule a time for you to take it. And then obviously reassessment will be available, and I can give you more details about that at a later date. Okay, so let's take a look at the Unit 2 study guide. You can find this at the bottom of our Canvas course. Okay, this is not a grade. You do not have to complete the study guide, but it is something good to look at and something that we will definitely be looking at that optional Sunday review session. So for each topic, I have a list of things that you need to be able to do. So for topic 1 on classifying subatomic particles according to their properties, you need to be able to identify the names and properties of the 3 subatomic particles, protons, neutrons, and electrons, compare and contrast them, describe the general structure of an atom, and define atomic number and atomic mass in reference to those subatomic particles. That would mean, knowing that the atomic number is the number of protons and that the atomic mass is the protons plus the neutrons, right? The number of protons plus the number of neutrons. You can find information related to this topic in the notes on atomic structure. So this was all the way back in September. Notes on atomic structure. Probably would be a good idea to review those before you take the assessment, even though you can use these notes during the assessment. Okay, next section is on isotopes. The outcome or the learning objective was for you to be able to determine the number of protons, neutrons, and electrons of an isotope based on either its name or nuclear symbol, also referred to as a isotope symbol. So let's go ahead and do an example of this. Let's say you have the name of the isotope here, lithium-6. Okay, well, this is one specific version of lithium, okay, one specific isotope of lithium. If I go onto my periodic table, here's lithium up here in the top left corner. It's got the atomic number 3. So let me turn all of my text blue here. Lithium has the atomic number 3. This specific version of lithium has a mass of 6. That's what that number is right there. Okay, so even though lithium's average atomic mass is 6.941, right, that would maybe round up to 7, that is not the value that we're going to use here for these specific isotopes. These are for specific versions of lithium, okay? And so that mass number is included in the name and the nuclear symbol for the isotope. Okay, so as I mentioned before in the previous topic, the atomic number tells us how many protons and for this unit, the number of electrons that are present in an atom of that element. So the real tricky part here is figuring out the number of neutrons. That's why it's so important to know the mass for that isotope. The protons plus the neutrons has to add up to equal the mass. Okay, so 3 plus something has to equal 6. Okay, alternatively, you can do the mass minus the protons, and that will give you that number of neutrons as well. And then lastly, for the nuclear symbol or the isotope symbol, this is going to consist of the element symbol for lithium, Li, along with the number 6 up in the top right-hand corner. Okay? Keep in mind the questions on the test are going to be multiple choice, so you don't have to actually write this out at all, but you do need to be able to recognize what these names and symbols mean and how to determine the protons, neutrons, and electrons in each of those. Okay. Moving forward, next topic is on calculating the average atomic mass of an element. So that's like figuring out where these numbers come from. You'll recall we did an assignment where you went to ptable.com and looked up information about different isotopes. And so that's basically what this assignment is all about. If you feel uncomfortable with how to do these calculations, I will give you 2 recommendations. Number 1, inside the average atomic mass notes, there is the formula that you need to use. In the video, I go into detail and actually do an example calculation. So if you are uncomfortable with that, I would recommend rewatching the video on average atomic mass. Alternatively, you can also just come to the review session on Sunday at 4 p.m. and I can do an example of that for you then as well. Okay, the next topic, I can represent an element's electron configuration in both standard and noble gas notations, as well as construct Bohr models of atoms based on that element's electron configuration. So once again, we did an assignment on this. This is kind of hard to do on a computer with just one screen. So once again, what I would advise, if you're feeling a little bit lost on that topic or you're feeling a little bit unsure about that topic, go back and take a look at the notes. There are 2 separate videos here for those topics. This first video is over standard notation. The second video is over noble gas notation and Bohr models. So take a look at those. And then once again, if you'd like to join me on Sunday at 4 p.m. for the review session, we can do some additional examples of this. Okay, and then lastly, Coulomb's law. Coulomb's law and periodic trends, that is the last topic. So you need to be able to explain how Coulomb's law works. You'll recall we did that simulation, learning how increasing the charges increases the force, increasing the distance lowers the force. So I want you to be able to explain that. And then we need to be able to identify and apply the atomic radius and ionization energy trends, okay, and explain why those trends are the way they are. Once again, if you're struggling with that, I would recommend taking a look at the periodic periodic trends notes. And then there's 2 videos that go along with this. The first video is all about Coulomb's law. Second video is all about the periodic trends themselves. So there's plenty of resources, but keep in mind during the assessment, you can't watch all the videos, right? So it may be a good idea to prepare ahead of time looking at the videos, okay? And then obviously, once again, if you want to see some examples of this, I'll be doing that Sunday at 4 p.m. In the optional review session. Okay, well, I'm going to leave it at that for now. I don't want to give you some super long video that you have to watch. So once again, sorry about not being there on Tuesday, and please plan on joining me Sunday at 4 p.m. If you want to see some examples on how these different questions work. Okay, thanks a lot, and I hopefully will see you on Sunday.